Hey, hello guys. Today we are going to learn about further in differentiation. Okay. So for this lesson, let's just based on how we can calculate the differentiation. So before that, we already said that we can calculate differentiation just using the formula like the y equals to a times x power of n, right? So the y differentiation can be considered also like dy over dx. That is for a times n and x part of n minus 1, right? So we already said that. But in fact, we doesn't know how is that, right? So now let's just prove how we can get this differentiation equation, okay? So let's move to this, okay? So first, let's make an example just based on y equals to x squared, please. Okay, so here's for y equals to x squared, right? So here we can start first just trying to draw the graph for y equals to x squared, like here, that is for y equals to x squared. Okay, so if you want to find the differentiation, also you just want to find the gradient of that, right? So maybe we have the 2 points. You can just consider here as x1, fx1, and this is x2, fx2. Okay, that is it. So maybe here we can set, if you want to try to find the differentiation for this, so first we can just consider the gradient m between the 2 points. Maybe here is a, here is b, right? The gradient between it is for y2 minus y1. That means the differences between the 2 points, right? The y value of the 2 point, right? And then you can also set, like here you can over x2 minus x1, right? Okay, that is it. And here we can set y2 minus y1 can also be considered here, that is for fx2 minus fx1, right? And x2 minus x1 can just written down x2 minus x1. So right now, if you want to find the differentiation or the differentiation of a, we said that is a gradient of a, right? So we want to find gradient of a, okay? But exactly here, we call the m is this line. Let me draw that. It's a blue line, like here, right? So we can just consider when the point B is coming closer to point A, that the blue line is coming closer to the black line on the graph, right? So we can say here, when B coming closer to A. So now we can just trying to refine x2, fx2 into x plus h, fx plus h, okay? Let's consider like this. So h here means a very tiny change right here, a very tiny change, okay? Like here. So we can just consider like the m gradient equals to fx2 here, you just consider means fx plus h. So here you can find, sorry, so here you can find that is for x squared, right? So when x equals to x plus h, you can say here y equals to x plus h squared, right? And then we have to minus fx1, that is for x squared, right? That is for x plus h squared minus f squared, right? And then divided by x2 minus x1, right? So we can say here x2 is x plus h and x1 is minus x, right? Okay, that is x plus h minus x. But then we can just trying to written down like this. So the denominator here is for h, right? And the numerator here is for x squared plus 2hx plus h squared, right? And then minus x squared. And then you can find that they delete each other. So here you can just set that is 2x plus h. And here we said when h is very small, just approximately equals to 0, so that the two lines are overlap, right? So here also we can just consider when h equals to 0, the two lines overlap. So just the value 2x here, okay? So you can say that is exactly how we can prove for y equals x squared differentiation equals to 2x, okay? That is for this problem. And maybe let's move into another proof, like if you want to prove like for fx equals to x cubed, you want to find that the differentiation equals to 3x squared, you can also prove that. So first, you can just set, we have 2 points, right? So here is for the first point, x cubed. And the second point is x plus h, x plus h cubed, right? So we said when the 2 points coming closer to each other, that their lines between the 2 points is very close to the maybe for the tangent across x, right? So we can say here the gradient m equals to x plus h cubed minus x cubed over x plus h minus x, right? So you can just calculate the a fraction number. So the first is x cubed plus 3h x squared plus 3 x squared h, and you can just set that is x cubed plus 3x squared h plus 3x squared minus x cubed. Oh, sorry, and then we have to add it h cubed minus x cubed. So here's for just only h, right? So x cubed and x cubed are delete, right? And you can just try to simplify it as 3x squared plus 3xh and plus h squared, right? So when h is very small, h is approximately equals to 0, so only we have 3x squared left, right? Because 3xh and h squared equals to 0, okay? So we can say here the x cube's differentiation is 3x squared, okay? So that's for this lesson. I hope you can understand it for how to calculate the gradient here, okay? It's very important. Okay, so that's for this lesson. So see you next time. Bye.